All right, let's do a little bit of review on what we already know about inverse functions. So let's say we have this function, f of x is equal to 3x minus 5, which we know to be a linear function, and we want to determine the equation of the inverse of this function. So we're going to start by writing the function using the variable y equals 3x minus 5. And then to determine an inverse function, what we want to do is switch the x and the y variable. So we get x equals 3y minus 5, and then rearrange and solve for the variable y. So add 5 to both sides, and then divide both sides by 3. We end up with y is equal to x plus 5 divided by 3. We could also split this up into two fractions. So it would be y is equal to 1/3 x plus 5 over 3. And the benefit of splitting it up into two pieces there would be that we now have an equation, a linear equation in y equals mx plus b form, where we could use the slope and y-intercept in order to graph the line. Now, since we know we ended up with a linear function, we could also use function notation to identify this inverse. So we could say that the inverse of the function f is equal to 1/3 x plus 5/3. Okay, let's move this up a notch. And now we want to find the equation of an inverse of a quadratic function. Okay, so the calculations are a little bit trickier, but the same process is followed. So we're going to start by rewriting this function using the variable y. So y equals -1/2 x plus 1 all squared minus 4. Now to determine the inverse, we want to switch the variables. So we're going to have x is equal to -1/2 times y plus 1 squared minus 4. Solve for the variable y. So we're going to start by adding 4 to both sides. Okay. The next thing we want to do is get rid of this -1/2. So we're going to multiply both sides by -2. Now remember, we want to multiply the whole left-hand side, so we have to put that x plus 4 in brackets. If we multiply the right-hand side by -2, -1/2 times -2 is +1. So we're left with y plus 1 all squared. Okay. In order to undo the squared part, we want to take the square root of both sides. Now remember, when we take the square root, we have to include the possibility that it's positive square root or the negative square root. Okay, don't forget that part. And finally, in order to isolate y, we want to subtract 1 from both sides. So we get that y is equal to plus or minus the square root of -2 times x plus 4, and then minus 1. Now, think for a moment about what this might look like on a graph. Okay? On a graph, we're actually going to be looking at two different pieces here. We'd be looking at the graph of y equals the square root of -2 times x plus 4 minus 1, and together with the graph of y equals negative the square root of -2 times x plus 4 minus 1. So you see here, this is the positive part, and this is the negative. The second part is the negative part of the square root here. Now from Unit 1, we already know how to graph each of these individual pieces. We would start with the parent function, y equals the square root of x, apply each of the different transformations. Now each of these pieces individually is a function, but together, so the plus and minus parts of that graph, this is actually not a function. You can actually go ahead and graph these two pieces together on one grid to take a look at what the inverse of this quadratic function h of x looks like. And maybe on the graph compare what that inverse looks like to the original graph of h of x.